Today we will start with Git and we'll see how it goes. So our agenda for Git is like we'll understand what is version control system and then Git architecture, how it looks like, and how do we install Git, and how do we create a GitHub account creation, and setting up remote repository, how do we do that. The post that we'll try to understand how do we do initial configurations to work with Git, and what is central repository and remote repository, deep diving into history of how do we exactly understand the commit histories, if at all we wanted to analyze the commit histories, how do we do that, and basic commands on Git. And we also look some few advanced commands on Git like revert, rebase, all this stuff. And we'll see main important thing, merging, branching, and we'll try to resolve the how do we resolve the conflicts, and then what are hooks, and what is exactly difference between the ESV and the Git. So these are all things we'll be covering today. Today we'll cover mostly these topics, and if time permits we'll cover a few more topics in day 2. Okay, so to start with, what exactly is a version control system, and then why do we need this version control system, right? So basically, if at all I'm having a team, say for example I'm having a folder in my Windows and I'm having a team size of 10 people. See, if they wanted to make changes of any of the changes of Java or .NET, any of the code changes, how do they do? They can do it on their local machines, right? So, and if I wanted to share with my code with another guy, so how can I share it? Either through emails or any of the drive. Similarly, I'll create one of the folder, shared folder. I'll place my code here so that the other guy will be able to take that particular piece of code and he'll be able to work, right? So likewise, people started using a shared folder concept. Okay, so the drawback in shared folder concept was if one guy is trying to update something, the other guy has to wait. So this was the drawback actually, which made the people or the team to think of going to some other mode of storage. So that mode was like central storage. Central storage in the sense they wanted to have all the code being maintained in one of the servers. Like let's say I have a server and I have a development team, and the development team will be interacting with this central storage. So we have central server where we used to store our code like SVN. We have SVN, CVS. CVS is kind of concept where folders, shared folder kind of concept. So CVS comes into this category, and SVN is a central storage wherein they used to maintain their code, and then developer used to pull the code and then push the code. So the drawback here was like, say for example, if my development team is in US and my server is in India, my servers are in India, and the teams are in majority of the teams in US, and then few are in India. So at this time what happens is like for the guys who are working in US, there will be a latency between the code pull push, right? Because it has to travel through the network to commit whatever history that they have made. So that is one thing, latency is there, that is one thing. And the other one was like as the server is located very far the main important thing that we'll face was the latency, and then we'll get to understand that if a person wants to pull the code, if a person wants to know any of the difference of what he has made, right, or difference with the previous one, right? So what was happening was, again, it has to the data has to, network has packet has to travel through the network, and then again it has to pull the results, and then he has to print on the developer who is trying to access the difference. Similar way, if he wanted to commit, if he wanted to do any of the he wanted to understand the commit history, he wanted to see the branches, for any request he is dependent on a network. So for any request he is dependent on a network. If network is down, what happens? There is no development. If network is down, there is no development, right? So that was the main drawback in going with central storage. So that's made, all these drawbacks made to think of something called as, again we have transformed or progressed to something called as distributed environments. Distributed architecture. So how exactly distributed architecture looks like is like, so it also looks the same way. We have a distributed server maintained here, and then we have our teams working here in US or India, and here we have a trouble of maintaining a server which location. But here what happens, we'll maintain a server at one location, and then we'll distribute the entire repository whatever we have to the developer machine. So first time it will be latency, and then next time onwards it won't be much latency. So we'll distribute the entire repository to the developer machines. But here also we distribute the repository to the developer machine. But what makes this difference? Here we don't ship the metadata. We don't ship the metadata. What is metadata? Metadata is nothing but the data that talks about the data, which means, say for example, I am having a I have written one.java file, right? So for this file, who has written, when he has written, why he has written, what he has written. So all this stuff are called as metadata. Why it's called as metadata? So this data is called as metadata because this data is talking about this data. That's why this data, who, when and why, is called as metadata. Fine. So that's where, I mean, what is the importance of having this metadata been transferred to the developer machine? So here we are getting the metadata also been cloned or shipped to the developer machine. So the benefit is like, say for example, if at all I wanted to do a difference, if at all I want to understand the commit history, if at all I wanted to understand anything about the data that has been available in the repository, I'll be able to resolve that particular piece of thing locally. And if at all I wanted to commit, I can do it in locally. If at all I wanted to do something, I will be able to do it locally. Even though this remote server is getting crashed or down, I will be still able to do my development activity, and will be still be able to continue my task for that day, because everything has been cloned. Even though this particular remote server has been crashed, I will be able to get this particular repository being pushed as a remote repository. So this was a major important feature that we had. And when we talk about the latency, as everything is being maintained locally, you need not, as you are not depending much on, only when you are trying to push to remote repository, only at that time you are trying to depend on a network. So as much network calls are not being made here, so the interactions with the different or number of developers that they do will not have much latency, and there will be more speed because everything has been done locally, and only the thing that you are trying to do is like either you are trying to pull and push and your clone. These three takes the network important. So you each and every developer will have a good network thing. So these are the main important features that we had, um, that we will get when we are going with the distributed environment. So what are the tools that we are available for distributed are like Git, Mercurial, right? So all these tools like Bitbucket and GitLab, all these
Are they
tools.
same network in the sense it should be in the same subnet, or it should be in the same IP address, or no?
No, no. See, network in the sense, say for example, I'm maintaining. It doesn't depends on a subnet or something because we are not dealing with any of the subnets. Say for example, you are a developer and then you are out of the subnet because you are not maintaining your machine in any of the subnets in any of the clouds, isn't it? Because you are getting your laptop and you are dealing with directly the server that is being placed in the subnet of a company's private network, right? Your laptop is not being maintained in the any of the subnets, right?
Mm.
It's in your company's network, that's all.
Oh.
So the servers that we maintain will be available in the subnets. It can be
Yep.
any of the subnets, but the topic that we are trying to talk here was, once we maintain our server in any of the subnet, if at all I wanted to do some difference, if at all I wanted to know about that particular piece, I will have to interact with the network, through the network. So for example, from my laptop, I wanted to understand who had made this particular commit, right?
Mm.
So then when I issue that command, here what happens in this distributed environment, it will be able to resolve it locally. And when I'm trying to push something, it tries to travel, that particular packet tries to travel through the network because it knows what is the domain name, right? Company name dot bitbucket.com, right? So it tries to, as that is a private registry DNS name, it tries to resolve that, and then it tries to hit the server that which is located in the subnet which you have placed. So here we are not talking about the subnets. Here we are talking about something called as network. From my laptop, how do I interact with the subnet, or with the server that is being placed in any of the subnets?
Oh.
Okay. So that's how there won't be any latency in the network, and then it will be very fast in interaction because we are less dependent on the network because everything has been distributed across all the developer machines, right? So that's why people started going towards or thinking towards the distributed environment, distributed architecture like Git and Mercurial. Like people are trying to migrate from SVN to Git, Bitbucket, GitLab, all this stuff, right? So this was one of the. I mean, this is how the source code maintenance has evolved, and then it has progressed till this environment, this architecture. And what is the importance of having this particular any of the architectures? Like, what is the importance of maintaining the code in one of the central location? So, if at all we are maintaining any of the code in one of the central location, which means that we are getting a benefit of sharing among the development teams. And another benefit that we get was like as we are sharing between the development teams, today we have only one code, and tomorrow we have some 10,000 lines of 10,000 files of code. We will not be able to uh, keep track of manually, we'll not be able to understand or will not be able to recognize who has done that particular change, when he has done that change, why he has done that change. Over a period of time we'll forget. So for that particular reason we should be tracking history, or we should be tracking things like, right, for that particular purpose we'll be having one central location where we place everything, and then we have to keep track of what my development team is doing. Version control system, it tries to maintain the versions of code that is being changed or updated or added. All this history is being tracked. So it is very important to track and to understand what has been done to the code in future. So that's why we need to maintain our code in one of the locations, and it's been versionized. Okay, so we understood that why we need a version control system, and it's okay, we'll see the Git architecture, and then post that we'll understand a few terms. So Git architecture looks like this. Okay, so this Git architecture, we call this as workspace. Let's say I'm having a remote repository, a folder name called as Amazon or Flipkart, right? Amazon code I'm writing. So when I clone, I'll get a folder here that's called as workspace. Okay, that's called as workspace. So this is called as remote repository. So I'm talking about something called as Git, how Git looks like. So whenever I clone the code, right? So whenever I clone this code to my local, I will be able to see a folder called as Amazon, which is called as workspace, and in which you will see a files 1.java, 2.java, any of the Java, and just star.java. These files, whatever you see, is called as working directory. It's called as working directory. Okay, so we don't see this particular area. It's called as staging area. And we have something called as local repository. So whenever we clone code, what we get was .git folder. Okay, so the .git folder, whatever we see, is called as local repository. And whatever files that we see in the whatever file that we see is called as working directory, and the staging area will not be able to see it. So this is how typically our Git looks like, right? So let's say now I have done some update to this particular, I have to do this particular update, this particular file, and then I have to make that particular file available in remote repository. How do I do that? So let's say I have initially one.java file was having a welcome. Now I will be introducing this triple exclamatory marks. So whatever you are maintaining, one.java, whatever file that you have in working directory, that also will be maintained in here, this local repository. So the same content will be there here in remote repository. Okay, so now I have this is what actually it was, and we cloned it was also having the same content, and then I try to make an update with 3 exclamatory. Now I have to get this change from local to my remote repository. So I have done this change in my working directory, and then I have to push it to remote repository. How do I do that? So first thing is like we have to make our change available in staging area, and then it has to be available in local repository, post that to remote repository. So we have few commands for this. First thing is like git add, either you can give file name, or if you are interested in submitting everything, you can give dot. Okay, like dot. So git add will make sure that the file content will reach here, 1.java, and then welcome exclamatory. The content has reached here, and now I wanted to move that particular content to local repository. The command that we have is git commit -m and the message. So this is what the command that we use to commit. When I say commit, -m is the indicates the message. What is this message? Message, which means that for what purpose are you trying to write this particular code, right? So for that particular thing, we will be maintaining it here. The information of why we have done this particular change. So now the file content gets updated here with, once we do commit, we'll get the content here. Now I wanted to push the content to this one, so I have a command called as git push origin and then the branch name, whatever branch name that you are working with. We'll understand what is a branch and what exactly it looks like, what is the importance of having a branch and all this stuff. For now we'll understand. For pushing the change, we have a command like this, and the change in remote repository will get changed to welcome 3 exclamations. So this is how typically we'll be able to make a change, or you can add a file, anything, or you can delete a file, and then from here you'll be pushing it to staging area and then local repository and then to remote repository with these commands. Any questions still here?
No, sir.
Okay. So this is how actually the Git architecture of distributed environment works. So as we are having privilege of doing any of the commits locally, we are not depending on a internet connectivity as well here. Pretty much everything you can do locally. Even though this because of natural disaster, if something happens to this particular remote repository also, you will be able to still have your tracked history in your local, so you can make this particular repository as a remote repository in future. So that's the benefit of this. Okay, that was the SEM terminology that we had seen. Workspace, what is a server and then what is a client? So what is a client here and what is a server? So this is called as server and this is called as client. So for why we are calling this as a client? So for example, you are working with a commands called as git add, git commit, right, git push from your local laptop, right? This is my local laptop, and where you are trying to execute all the git commands, right? So when you are trying to execute git commands, does the machine understands the git commands? No, right? So to make our laptop understand, what we have to do, we have to install git. So we have to install git. It means we are installing something called as client software. We are installing git client software on our local PC, which will make the OS understand, Windows OS understand that whatever command that we are trying to execute, it will be able to understand, and then it will be able to do accordingly. So this will act as a client, and then this will act as a remote repo. Okay, so now we'll understand what is a branch and what is check-in and checkout. So check-in is like kind of a push, and checkout is like again a pull, right? And revision is like whatever commit that we are trying to do here, that commit, that whenever you are executing this command called as git commit, which tries, what it tries to do is like it tries to do a snapshot, or a snapshot means difference, like what is this change and what is the files, each and every minute details will be captured over there like snapshot, and that will be converted to one of the hash, which means one of the id, revision id, that's called as revision id. In normal svn or something we have some like in numbers like v1 v2 v3 something like that, and here in git we have something called as 40 character length sha value, which indicates the change or snapshot of what was the difference for that, for the at that particular point of time. So whatever change that you have done for whatever files, that gets converted to a hash value with 40 character length, and it's been stored in .git. That's called as a revision. Revision is nothing but a SHA or version, kind of versioning. So we have commercial tools like Perforce, ClearCase, and then TFS, and we have open sourced like SVN, CVS, Git, Bitbucket, Mercurial. All these are distributed. And why people are moving towards Git is like because of speed, and if you wanted bit more features, and then we can go for all of them. We have paid and then non-paid things, but for GitHub we don't have any of the we can create both private and public repositories for free, and we have a Bitbucket, and then we can also create public and private repositories in Bitbucket as well. But if at all we wanted to have a company things, then we will either try going with the enterprise versions. So enterprise versions comes with its own features, like you need not worry about the server maintenance and all. The Bitbucket company itself will be able to maintain all the servers for you, and it will provide a few of the other benefits. Okay, this is how actually whatever we had discussed. We also called as the working directory. Here whatever we talked about is called as working tree. Some people call it as working tree also. So from working tree we will be doing some change and pushing it to staging area, and then we will be doing maintaining it in local repository, and then pushing it to remote repository. We'll understand what is stashing going forward. We'll see what exactly it is. Now we'll see how do we install Git. Okay, so how do we install Git, and then what are the commands to install, and then how do we remove this particular Git installation. Okay, so before that we'll start knowing how do we have our Google Cloud Platform account been created. So everyone has their own Google Cloud Platform account.
Yes, Karthik, I have created.
Okay. So we'll do one thing. As soon as we'll stop here, and then this is an exercise for you guys for installation. Installation is like just like sudo apt-get update install git, which will install Git, and then we'll try to see what is a GitHub account creation, and then how do we interact with Git, all this stuff, and we also see how do we add a remote repo, all these initial configurations. When you do some if at all you wanted to, we'll understand this particular adding an origin. The reason why we add an origin is like if at all we are maintaining the 3 repositories, and then if at all I wanted to push to different third repository instead of pushing it to first repository, so how do I do that is what this one. So we need not worry about it right now, and our target is to install Git, and how do we interact with the remote repositories, right? And a small exercise for you guys: once you create a Git repository, you try to create a file, clone it first, the repository that you had created, and then create a file, add a file, commit, and then push, and then you will see the log of the particular file. So this small exercise we will be trying to do tomorrow. Okay, so try to install and then try to do this exercise. Okay, so we'll start with tomorrow's session. Again, we reiterate the day one, and then in 5 minutes, and then we'll proceed with the day two content. Okay, setting up the configs and setting up the local central repository locally and all this stuff. And we also understand deep dive of history on Git. How do we have our logs and all this stuff, and we'll understand how do we remove, how do we move. Then we'll talk about third day we'll talk about branching, what exactly is the importance, and then why exactly is, and what kind of models we have, and what in real time what do they maintain, what kind of branches they maintain, what are the release, what is hotfix, what is bug fix, what is feature, all these branches that we will talk about, and then what its importance, right? So as of now we'll stop it here, and then we'll continue from Google Cloud platform creation tomorrow. So I think we have already sent you the Google Cloud creation document. So please, if at all you guys don't have it, so try to create an account tomorrow, and then we'll start with installation, and then we'll proceed till day two topics being covered tomorrow. Any questions, guys, still here?
No, Karthik.